After a few iterations of modifying the stiffness of the spring and checking the eigenvalues of the system, we now have obtained a reasonable value resulting in 1 Hertz. This is now the value that I've obtained by just testing and retrying. I've come to a value of 1000 Newton per meter with a damping of 1 Newton second per meter, which is quite low damping, and we'll check the frequency. The frequency being indeed almost exactly 1 Hertz with 0.16% damping. So that's quite low damped, but I'll illustrate to you why we're doing this. Well, actually you would think that with this frequency being 1 Hertz and the input frequency being 1 Hertz as well, you would actually expect that if you would hit the ball, it would oscillate exactly in phase with the piston. And let's see what the simulation is telling us. Well, not quite. This is getting a quite erratic simulation. But the reason again is quite simple, but that's the fun of visualization. The reason why it's getting so erratic is because the frequency of the pendulum does not remain 1 Hertz. The hit by the piston is that big that it just goes to a bigger value, and therefore the frequency changes. Now if we would change the length of the cylinder, just giving a very small hit to that ball, and I've already tried it here so I can easily change it back. Okay, now I'm making the length of the cylinder smaller, therefore making the impact smaller. And if I now try and run the simulation again, with the amplitude of the piston, of the boxing ball remaining smaller and the frequency therefore being closer to 1, we indeed see that there is a quite good phase between the 1 Hertz input from the motor and the 1 Hertz response at the boxing ball, which is what we wanted to achieve.